routine impression taking. Here we get the impression out of extraoral scanning, and this is the procedure of CAD designing. So we will show you some data. I just want to hide this. Am I still sharing? This is crazy.
हाँ राजकुमार जी कोई दिक्कत?
हाँ somehow I'm not able to see my screen properly. Whatever reasons, anyway. Scan each cast one by one. Scan the cast with wax rims in the place. Establish the pre-scan individual cast into jar using the wax rims. And okay, we go into the CAD software, the full denture module. And this is the process we start. Maybe you have to bear with me. Yesterday I recorded this, and if need be, we can just, I need to transfer the file. This laptop is very slow. I'm trying very hard to transfer the scan data into this. So I could show you the live. I could still do it, just let it continue. I copy the data from the other PC. It is just too slow, so it's not allowing me. Anyway.
That happens in online presentations. System
Yeah,
is.
I know it is just very irritating.
No, don't be bothered. It's okay. Let it take its own speed. Please don't worry.
Yeah, I want to tweet and it is becoming like a turtle. So here we are importing the scan data. This is very important that wax rims are also scanned. Normally it is difficult to scan the wax rims because the wax has, it is not seen by the scanner I mean. So we spray something and then scan wax rims. Now it is a beginning of designing. First we study the model. We place a point on the left side of the model. Then on the right, the center, and the occlusal plane is established. Here we determine the papilla and velocity. We can move. I could still show live today for this the same file preparation, so that I can interact with the participants. If there are any points missing or not able to be grasped by the participants.
We can understand.
Yes, of course. This is never a rocket science, but like something when it is new,
yeah.
So it looks unfamiliar. That's all thing which I wanted to say. The last Ruge points, the first Ruge points I mean, and for the mandibular, on the frenum, the buccal frenum, we place the points. If time permits, doctor, I could show one arch implant designing live, but let this complete first.
Okay. You ask him to take the permission and
Here
leave.
is identifying the ridge area by this orange line. And auto detection of molars. I'm just pulling one blue dot distally. The model identification is almost complete. Then there is auto teeth placement. Now it is interesting here to note, doctor, the distals, premolar and molar, the group of 3 and 3, either side, each. They cannot be moved individually. They have to move in group. So I'm just enlarging them to bring it to its normal size. Just bringing it in occlusion. All this is quite relatively simple compared to implant designing. Manually bringing it into arch. We have to take up this left side. This is bit tricky here at this juncture. So a little familiarity will solve the purpose. Dr. Mehrotra, if you suggest, after this I could do a live designing also, or we could jump to implant designing, custom abutments, and one example of bar. So this could be interactive. If anybody wants to ask anything, I would be able to understand and reply. Now bringing one teeth each. What is interesting to note here, that all teeth either we could choose from a teeth set available in market, or we could design individually, and these teeth can be milled from a good blank. So it doesn't matter whatever is the mold size, whatever the height and the requirement, we can just design freehand CAD and mill it accordingly. So it makes things much more easier. In conventional technique, the available teeth you have to fit somehow and you have to really struggle a lot. Now when teeth are too close, there has to be that green dot on the mesial and distal side of each teeth to allow that the intersection is minimal. But still we can solve the intersection later by one click to fix the proximals. Nishan? Sound off. This fine tuning takes a little longer, but doesn't matter. I would say this is a lot easier compared to doing a individual teeth setting.
How do you move individual tooth, like using a mouse, or there is some
Mouse, mouse and shift and control button. Now here we can fix the contacts by these intersections, cut intersections. Now it is propping up the insertion direction. We can change the intersection, the insertion direction. Now what you see in little light brownish area, these are the undercuts. We can fix the undercut by smoothing also, but if it is like avoidable, we can avoid it, because these areas are very critical to retain the denture very firmly. Now my whole point is why digital denture? This makes the retention so accurate and so perfect. It doesn't press the mucosal area anywhere in the patient's mouth. So it doesn't have the hurting feeling, the mild denture. We go a little fast. Here what we see in green, we can slightly touch up, and especially the frenum. The denture should not hurt the frenum. So we do a kind of a smoothing. So smoothing doesn't smoothen the scan data, but it gives some buffer layer to avoid the denture material coming directly in contact and pushing the frenum. So it is comfortable for patient to wear the dentures, and if undercuts are too acute, it can be minimized. Now, the insertion direction, whatever has been given, it is processing, the computer in the background, processing to develop a denture base. So it does take time, but if PC is fast, it can be processed faster. Marking the lines. This is for the phalanges end area. This is by mouse. We click the points one by one and double click joins the lines. This is defining the area of the denture base. Now the teeth as we designed. for the mandible. We are clicking the points one by one and moving forward. Now processing to prepare the base, denture base, and you see the teeth in shadow. Now we can design the gingival area. We can pull down the gums or take it up to understand what could be the teeth length. If teeth length is to be changed, we can change with the modifications of the gingival contouring. The best points is that what I have delivered the dentures yesterday, Dr. Swati was asking. I wish she could experience the fit of such dentures, milled dentures. By virtue of me being a hyperdent application specialist, I can design the milling templates for denture and fine tune like anything. So the fits are amazing and they just don't fall out easily. They have a good retention, a balance of retention and balance of not overpressing the mucosal area.
What would be the lab cost of these milled dentures?
It's approximately 11,000 for upper and lower.
11,000 upper and lower included. And will that include fit-in, check-in, try-in denture also?
Yes, yes. You can take this trial. You can use that as a pre-op. Yes, that can be also very useful because many times if jaw relation is not gone correct, then I'm afraid very little we can do. But what we can do here, we prepare the denture base, which in any case will not change. And then we can give a teeth trial, what we have done.
Okay.
And then in the mouth, trying can be done. The teeth can be altered, height by fixing with the modeling wax. And then probably we will use that as a pre-op. So computer
As a
allows,
final try-in base.
yeah, so computer allows us to copy everything according to the pre-op, the JR in particular.
Okay.
So these teeth are finally glued. I use a Brident gluing agent, that is visual ink. First we apply a primer and then cure it and then apply the visual ink on the base and teeth together. We are just attempting to give a festooning. It is a suggestive kind of thing. It is as per the individual discretion. How much characterization to be given. Another good thing is, doctor, that with the composite, use of composites, we can give characterization. Like we can enhance the aesthetics of this gingival area, like the palpability can be seen with some color effects, which I'll give you a picture later. So it can be made to look very live. Now later, I was preparing it little late in the evening yesterday, so some error happened, but I think that can be overlooked. What is important to all of us is that tools that I provide to understand how to design it. So I'll request all participants to concentrate on the tools, the CAD tools available to give a good look, good design. Just smoothen it if it has gone too deep in. And ma'am, this is all real time working on the CAD.
Yeah, thank you.
Thank you, doctor. So here we are. We can choose the anatomy of teeth from the library. We can still do, all modifications can be done even after the designing is complete. We can go towards the end and there is a click of redesigning, or there are tools available to do fine tweaking anywhere required, even after the designing is completed. So it's as per the designer's choice. He can do whatever he likes. Now, whatever green and red area you see is the thickness of the denture, which we have selected 3.5 mm. So here is the top, it's a 0.35, no, this is, it is processing to complete the fabrication. The minimum thickness I had chosen 0.35 mm.
So are you using denture, printing denture with teeth, or separate base and teeth?
It is separate, doctor. There is no printing business
Milling.
because
Yeah.
printing doesn't yield the quality that we are looking at. Printing is like a very soft term business, short term business. The longevity of the printed dentures are not good enough.
Okay.
So when we mill the denture, firstly it is free from any unpolymerized content of the denture, because conventionally the polymerization is often not complete, and that is irritating to the soft tissues. So from a fixed blank, hard solid blank we mill, so we ensure that polymerization is not an issue, so it doesn't hurt the tissue in any way, the monomer liquid kind of thing. So that is also a big advantage. Fit is great advantage. Tooth you can modify to individuals' jaw relation, height, and the mouth size. So that is a big leverage we have in freehand designing. Otherwise, the patients, they open the mouth and you can say, oh, it's a dentsply kind of teeth, rock teeth or sinew teeth. This is a freehand design teeth, and which matches with the face, the smile and everything. Here inside things have not gone well. So I honestly agree. I could have done it better. Now I want to show this is the denture base, and teeth and dentures are separately milled. So just smoothing. Now it is complete. Just inspecting a final look. These are the tools which allows to redesign. I just freeze the frame here, and okay, it is the bar is hiding the buttons. Uh, there are all the tools available to attend to any area, any deformity which we feel that it needs to be corrected. So this brings to completion, and yeah, it has taken a little longer because I was doing it after a long time. My colleagues do it, so I am like free from attending to this issue. It is now merging. You see the blue line and the orange line. The process of merging is going on. Now, whatever is these are the teeth sets. You can see from top to bottom, they are individual teeth. So we mill individual teeth and we just show the denture base. This is the denture base, and okay. And the gap, cement gap, which we have kept, which is approximately some 4 or 30 or 40 microns. So the teeth are fixed, they are put very nicely. I'm just selecting and bringing them all, these teeth for upper. I think recording ended here. Uh, I had some more to show, but maybe that screen recording was not allowing me to go further. So now this is part of designing the denture. I attempted to record, I think, again. Okay, this is for these are the effects we can produce, doctor. Go into the slide mode. We can do the characterization. This is the area which I wanted to highlight. There are some lila, rosa, and beige color. So a mix of those composite colors can give a very live effect. This is teeth also from Bredent, which I used. So I took the library of teeth, inserted onto the denture base. Once the denture base is milled ready, then we can insert those Crea-line or Nova-line teeth. This is from the Bredent. And the milling process. In the milling process, the material available today is a pink PMA, a pink graphene, which has a very long life, 10 years, 12 years, no issue. And the pink peak polyethyl ether ketone, which is also in the market for some time, maybe about 5 to 6 years. Other pink composite blinds, if available, of height starting, usually the height goes up to 30 millimeter as per the height of the maxilla. Blanks for teeth, we can choose the routine PMMA blanks. We can choose from the composite blanks. There is a very interesting material available from Brident. It's a Bricam Multicom. It's a multi-layer. So the teeth aesthetics are absolutely very high. Then milling tools, this is also critical. I designed a strategy to finish the milling faster. So these are the suggested by standard companies, but I go with a flat tool of 4 millimeter, which does the gross reduction of the material very quickly, and maybe the milling is complete in about 1 hour and 25-30 minutes. So, and then we can also use end mills, flat tools to create the sockets and define the sockets that erases the endpoints very well. And the milling machine has to be either 3+2 or simultaneous 5-axis. If anybody wants to know what is 3+2 and 5-axis, I could just throw a light on that. Gluing protocol I mentioned already, that how to glue. There are different gluing agents available from different companies. What I choose that I mentioned. Characterization of gingiva with papilla using effect producing composites, and then finally finishing and polishing. This is the pink denture and the teeth. This teeth available milled from Bricam Multicom. These are the features and benefits that we can customize individual tooth. Accuracy achieved as no volumetric shrinkage, because in flasking and packing, there is some dimension alteration, but in milling, there is no dimension alteration. So it is a predictable fit as compared to conventional technique, which is in any case going to shrink. Even if it is 1 or 2%, it can affect the soft tissues, and free from any polymerization issues. It's a very time effective. You saw that quickly we can design the denture base and teeth. It is more reliable, better consistent as the unique feature of a CAD/CAM system. The unpolymerized polymer content reduced. If you choose the PEEK material, it is amazingly good for the tissues. Strength is too hard. I mean, if you use a PEEK denture milled out of PEEK, it is literally unbreakable. And yet it is so inert, it is completely tissue friendly, and aesthetics are always good. So shall we go over to some designing, doctor, or we
I think
conclude?
we should cover implant part.
Okay. Okay. So I just, but you have to allow me some time, doctor,
Yes, please.
to emphasize on the points which I feel are necessary.
Yes, I have another meeting at 12. So till the time we are available.
At this time, we don't need so much of time. I thank you for allowing me a little time. That would be enough. I just need to check what are the files I have copied. I just need to copy again. Wait a moment.
In the meanwhile, can I ask a question, please?
Please, sure.
Can we reline a PEEK material?
Go. But why would you need to reline? Just my.
Let's say a year after patient comes and the denture is loose, and we think that everything else is all right and just a simple relining would do. So since PEEK is a nylon based material, so can it be relined? Because I have not read as such on the literature that it can be relined.
Problems have been happening, doctor, because of that unpolymerized kind of quality of acrylic. So the recession or reduction of the volume of the mucosa is responding to unfavorable denture material. So it ends up like, if you start wrong, it is going to end somewhere. But the quality of denture that we do, okay, fine, acrylic is okay, PMA material, that can be relined. But when it comes to PEEK and other graphene materials, they're so tissue friendly that tissue will not respond in a hostility. They are friendly to each other. So the mucosal reductions are very unlikely unless there is some clinical problem with the patient. Because of denture, the dimensional alterations are very unlikely.
So it cannot be repaired or relined.
Repairing you don't need because they don't break easily unless you hammer it. And relining is tough, I know, but imagine if patient is affording, he is having the quality of denture fit. The quality of fitting is far superior. Now, if you eliminate one possibility of relining, as long as patient is wearing a good quality fit denture, is he not enjoying his quality of life is also better
No, that's
compared to.
besides the point. I am not doubting the capabilities of peak or the milled peak material. I was
I'm
just wanting
the
to know
cost.
whether it can be relined or not. I
I,
should know because
yeah,
as
of
flexible
course.
dentures, flexible material came into market, it was being prescribed right, left, center, and then in not so experienced hands, the patient when came back to doctors, they get lost because then it would require additional almost double the thing for doing it correct. So my question was regarding that only. What you
I
are saying is right, that peak is a very good material. For me it seems like master of everything. You name it and peak can be milled into it.
it's a
But then
yeah. I do as a clinician's anxiety that if patient comes up with some new problem which are unseen, unknown, then how to handle
yes,
that problem. I imagine
yes.
that condition, uh, a nightmare of a dentist. But here, if the quality is the material property is such that it will reduce the anxiety of the clinician, unless patient has some other clinical problems.
So since it cannot be repaired, so it cannot be used as a transitional prosthesis. And since it cannot be relined and repaired, we need to be very careful about the residual ridge resorption state. Meaning that if we have a freshly extracted case, a patient with 5-6 extractions done 2 months back and all posteriors, then we'll have to think twice about giving peak, because
Yeah.
in such a situation at times after a year, the resorption, when it settles down, the maxillary or mandibular, wherever the extraction was, the denture gets to become a bit loose. And when the patient is paying so much, the patient would not want the doctor to say, oh, it cannot be relined, you need to get a new one made. So I am not doubting the capabilities of peak, but yes, we should know that it has its own indications and should not be considered that you use it and everything would be good.
I fully respect that point that you have to allow the tissues to settle down post extraction. Like if you do extraction and the patient has a lot of money, then it's okay. You can give immediate, you can give.
Yes, yes.
So that's perfectly all right. It's like going to buy vegetables in Mercedes and going long distance also in Mercedes. So
Yes.
drawing an analogy that a patient can afford, fine. But yes, a clinician has to justify the cost and he has to find the right suitable condition. Now is the time we can take the impression and go for this uh, CAD CAM dentures. But as long
Yes.
as you have not settled down, you are absolutely right, madam, that we have to appreciate those conditions and take a very wise decision.
Yes, sir.
Okay. So, yes, material property understanding is foremost and utmost necessary because it should avoid any embarrassing moments for the clinician and the dental technician both. I'm just transferring the files here. Uh, we have a 4 implant case. We'll choose a model, the digital model, and proceed with the custom abutment design or maybe a bar design. Doctor, would you like to give any choice of first designing a bar for hybrid denture purpose or a custom abutment? You can make a choice and then I choose, take the order accordingly.
Swati, your choice.
I missed the question. Ma'am, I missed the question.
My question was, doctor, that since you can see the model, which is a 4 implant placed in the mandibular jaw, and then if according to the height availability or the decision of the clinician, we can go for a cement retained PFM bridge, or we design a bar, mill in titanium, a screw retained bar, and use that bar with the spikes to prepare a hybrid denture. So what kind of framework? We can also give a demonstration of how to attach the attachments, how to place the attachments, extra attachments for extra retention in case it is a telescopic. So we can give you choices for all 3 at the moment. There are many more choices available, but right now a custom abutment or a PFM or any other material, we design a framework and then make a PFM. Next is we design a bar for hybrid denture purpose, and third is for the telescopic purpose. So the 3 questions, 3 options in this question. You suggest me and I take the order accordingly.
The screen for that case is not visible. All I can see is a denture.
Okay, let me, now can you see it? 4
No.
implant?
No, not on the screen, but he's holding in it in his hand, the model. I think we'll
This
go for
model?
custom.
Custom abutments.
Yeah.
Okay, because you can see on this side, the angulation is a little over 28 degrees.
Yes.
So let us design a custom abutment. That also can be exciting, but we can show both. It doesn't matter. First custom abutment, the same model we can show next, bar for hybrid denture purpose. A milled bar in titanium and prepare that bar for hybrid denture purpose. So we do a CAD design.
A hybrid denture would be more efficient if the crown height space is good enough. But if it is less than 14 mm, then maybe we can think of giving a screw retain like a FPD model.
Yes, we can design that also. Why not? We can have a screw retained a PFM sort of. Just screw in the whole framework, and PFM is layered with the porcelain already. So we can mill that framework in cobalt chrome, because titanium is tough to bond with the porcelain. So the choice goes for the hybrid denture or a custom abutment, Dr. Divya said. Here I choose this, maybe 5.
Can you let us view your screen, because we are stuck up at the old PPT.
Oh. Wait. Is my screen seen or not? I'm afraid I'm not so tech savvy. Can you see my screen, doctor?
No, not
No?
as of now.
That's very sad.
You will have to share screen again.
Okay.
Try sharing again.
Can I log in again?
No. You don't need to log in. Just click the share screen icon.
No, it's not allowing. I don't see that. I can't open the share video, that icon. So, okay,
You are the co-host. You can
wait.
share the screen.
Yeah. Okay. Do you see my screen now?
Yes, it's starting. It's going to. Yeah, we can see it now.
Okay, great. I get very scared in such moments because if I cannot show the desired one, my efforts, like I feel very miserable. Uh, so here we are. We have taken the order. If you want, I can repeat. This is order page where we write down everything, write down the technician number, and then we choose the teeth, which according to this model, left 5, and we choose for coping. First, we are going with abutments, I believe, custom abutments. Is that right, doctor? Am I going correctly?
Yes, please.
Okay, thank you. So we choose NP metal, non-precious metal. I just need to hide because I can't see implant, screw retained custom abutments, abutment material. Wait, I don't know how to hide this. Yeah, I can hide it now. Good. So you can see the tabs which I want to show, doctor. About material, anything which I want, non-precious metal, laser, whatever. Scan a pre-op model. I'm not taking that option. No. Scan gingiva separately. Yes. Design virtual gingiva, that is in case of Malo bridges. So not required. Design with thimble crown workflow. No, because it is on custom abutment. Cervical adaptation. Preserve tooth library. And these are the parameter values for the cement gap for the custom abutment supported processes. Thickness of superstructure 0.55, shrink 8. Now these things will be known when you go through it once or twice, it becomes familiar. So here we are. Now we save first the whole project, and this 5, I apply the same parameter by control and choose the teeth, which is tooth number 31, 32, 42 and 45 again, and rest is reduced pontics. To apply this parameter to 31. This is order saving. We have taken the order, chosen the pontic and abutment supported, and we go for the designing. Please excuse me, but the laptop is too slow. It is adding to my problems.
It's okay.
Thanks.
We are with you till 11:55. So
That is lot of time. That is lot of time. But I just wanted to, this should not take up our precious time. That is all my concern.
yes, I
Okay.
understand.
Okay. Now we choose, browse the file which we are looking at. So desktop, and we go to the scanned data.
Are you using a gaming laptop?
I never game. My age doesn't motivate me to game.
I think these softwares run better with a gaming laptop.
Gaming, they have that GTX kind of graphics, but we use this NVIDIA graphics. So that allows the CAD working better.
Okay.
Because here the frame per second is not so necessary. It is the stability of the graphic CAD is necessary, because finally we mill it.
Okay.
So milling has to go very accurately. The data transfer should be very accurate. Ma'am, I just allow me to, I think this data is not transferred properly. Where is that? Just a moment. My main PC doesn't have a camera. Otherwise, these things will be very smooth and fast.
Can I disturb you with one more question? I'm sorry.
Please go ahead, please. I
uh,
much
I have
comfortable
used
answering the question than handling this lousy laptop.
so maybe we'll take them later if there is more time.
Yeah, it's almost done, but I can still continue to answer, doctor, the question.
Okay. The problem which I face with DMLS frameworks for implants is the lab gives me a third party screw. Like if I'm using Ostem, then I want to use my Ostem screw. I tried using it, but those Ostem screws don't fit in, but the third party screws are fitting properly. So I am slightly apprehensive as to what is their strength and what quality material is that.
Ma'am, the first thing what is not appreciable is that for using the screw retained processes, they must not be printed. They should be milled. Otherwise, why do you think companies spend crores in having a milling machine? These printers, DMLS printers are available easily, a good quality, could be around 1.7, 1.8 crore. So any implant manufacturing company can have these printers, and they can be much faster in producing these. The reason is the printed objects where the screw fit area, which should be 90 degree, it is curved. The printing is never, it doesn't provide you the perfect right degree, 90 degrees angle. That is possible and achievable only by milling. So how do you think, in fact, you are damaging the whole processes? The screw will, it is just joining not with the bottom flat area of the screw, but the edges of the screw. So it is either going to loosen out very soon, because there is not much flat surface available for the screw to hold on to the process and the implant firmly. So only milled object are successful and good enough, and then you can use the company's tools. Why do you think companies spends a lot of money in fabricating their titanium screws? Because they know, they understand, they know the material property, they know the structure, they know the surface very well, they have studied it so much, they have researched it. So we cannot belittle their efforts, the company's efforts of research and development. So we should follow the protocol. Otherwise, this printing, though it is shortcut, but it is going to create a lot of problems. What if implants also get damaged? Okay. So that is why I would say that please consider either milled custom abutments. The printed ones should be avoided. So with milled, you can use company screws and life is assured.
आपसे बोला भी नहीं सुबह उठा था
Okay. We have load lower jaw. I'm loading the lower jaw and gingiva. First, we have to align with the insertion direction, and then it is you can go to the next stage. The smile creator is unnecessary here. We don't have the information of the patient's photograph. We go to the next. My screen can be seen easily, doctor?
No, we can't.
Oh
It's
my
stuck
God.
up. It is stuck.
The frame is frozen, you mean, doctor?
It is frozen.
Just wait.
Can you share screen again? Stop sharing and share again.
Yeah. This is crazy. The button doesn't open.
Okay.
It was a beautiful case to show for custom apartments, and I would be very delighted to share this piece of information, how to design custom apartments, and then how to design processes. Is it possible if my face is not seen?
Yes, then it's fine. It's fine. We don't need to see your face. Just your
I know
screen is
it's
good.
not so present either, but I was saying that we can shift to another PC. That was my whole point, because that PC doesn't have the camera, but the speed is good enough.
Does it have sound system? Can it?
I have a microphone, headphone.
Okay.
So we can connect and we can design things much more better. So I'm just trying to connect from there. Can I quit here for a moment?
Yeah, please. How much time it's going to take? We have only 10 minutes left.
So I think 10 minutes also we can manage.
Okay, then go ahead.
Yeah, let's see. No, we think better we interact, because let us not waste our precious time. So we can interact. So that is one answer which I gave on the company screw not fitting on the printed objects, and we should avoid it.
Any other question from the audience? Anybody else wants to ask anything?
With related to implants.
Can we schedule it tomorrow? Same time? 10:30?
Okay, no problem.
So
Done.
then we have sufficient time?
Yeah, sure.
So implant part, whatever 2-3 modes you
Because
want
I
to.
have to present. Yes, it's a
So,
wonderful idea.
yes, then we go ahead with tomorrow's presentation of yours on implant supporting.
That will be great.
Yeah. Okay.
That will be
Thank you so
better.
much.
Thank you so much. Bye-bye.
Bye. And tomorrow you can log in from your desktop.
That would be better because only audio and the screen sharing is important.
Yes.
Lucknow.
Yeah. Thank you. Thank you, everyone.
Thank you.